Hello guys, welcome back. In this video, we will learn about point, lines and line segment. Then we'll see the properties of parallel lines and transversal lines. Then we'll see about polygons and its properties. So let's get started. So what is a point? So point is nothing but a location in space, and it has no dimension. So what you mean by dimension? If you take any real life object, let's say a scale or a pen, let's say a pen. Okay, so if you see, it has height, it has some length, and if you see in the third dimension, it has some breadth, right? So we can say this is a 3D object, three-dimensional object. Suppose you just have a paper. The depth of the paper or height of the paper is very less, so we can ignore that. So then we say there are only length and breadth. So we can say it is a 2-dimension. If you take just one straight line, it is a 1-dimension. And if it's just a point, we say it is 0-dimension or no dimension. And usually when we represent a point, it is equivalent to saying as specifying a particular location in space, right? So that is the point. Now you take this collection of points and put them in a straight line, collection of points, and you connect them, so you get what is called as a line. So line will usually extend in both direction infinitely, and it is straight. If it is straight, it is called as a straight line. And in general, line is said to be straight. Then what is a line segment? It is a segment of a line. You take this segment, let's say A and B. So it has finite width, so finite length we can say. Then it is called a line segment, right? So we'll also see what is a plane. So plane is nothing but a 2D figure. So it is similar to the paper I said, right? So paper is considered as a plane. So on this, if you draw a line, then it becomes a line segment. Now imagine this paper itself being infinitely long. So the plane is infinitely long in both directions. Actually, it is in any direction, but since we are considering it as length and width, let's say along its length and width. So then line also can be infinitely long, and you take a part of it, segment of it, you call it a line segment. Now we go to the concept of parallel lines. So if you take any two lines on a plane, let's say line 1, L1 and L2, and this is some plane, let's say. And so if you take these two lines, suppose you extend these, so there is some point where they intersect, right? So there are also lines like this, L1, L2, such that when you extend them, they will never intersect. So this distance is always constant, maintained. You can see here this distances keep on reducing, and finally it becomes 0. But here the distance is kept constant. So these lines are called parallel lines. So they do not intersect, when extended infinitely. Okay, then we'll see what is a transversal line. So transversal line is nothing but a line intersecting these parallel lines. See, L1, L2 are parallel. So this is the symbol for parallel. So L1, L2 are parallel. So this L3 intersects both L1 and L2. So this is called as a transversal line. So there are very special properties for this transversal line. So you can see there are many angles formed, right? So these angles. So let's name them. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. So there are 8 angles formed when L3, which is the transversal line, intersects the parallel lines. So there are special properties. If you see in any line, if you have this kind of thing, this total angle is 180 degree. So angle 1 plus 2. So angle 1 plus angle 2 is 180 degree, right? Okay. So that way, if there are special names for these angles called corresponding angles. So what are corresponding angles? So 1 and 5, you see they correspond to each other. So here also it is above this line L1 and to the left of L3. Here also it is above line L2 and left to L3. So angle 1 and angle 5 are corresponding angles. Similarly, angle 2 and angle 6, angle 4 and angle 8, angle 3 and angle 7 are corresponding angles. So the property is corresponding angles are equal. So you may ask how or why it is so. So another thing if you observe is angle 4 and angle 5. So this is also 180 degree. Why should this be 180 degree? Suppose if it is less than 180 degree, then what will happen? You know a triangle, right? Sum of angles of triangle is 180 degree. So this angle plus this angle is less than 180 degree. Then it means that this will somewhere in the point as we extend they will meet. And if they are greater than 180 degree, what will happen in that case? If these are greater than 180, these angles will be less than 180. So they will meet on this side. So that's why, since we assume that they are parallel, these sum also should be equal to 180 degree. Okay. So now what we want to prove? Angle 1 is equal to angle 5, right? So what we have? So we have angle 1 plus angle 4 is also equal to 180 degree, and angle 4 plus angle 5 is 180 degree. So right hand side is equal, so left hand side should be equal. So angle 1 plus angle 4 is equal to angle 4 plus angle 5. Angle 4 cancels. So we have angle 1 equal to angle 5. So this is the first property. Corresponding angles are equal. So there are 4 pairs of corresponding angles. The second one is alternate interior angles are equal. Alternate interior angles. So what it means? So if you take this part, if you see 4 and 6, they are interior to between these lines, and they are alternating, like one is on the left side, one is on the right side. So these are equal. Similarly, if you 3 and 5, they are also inside and on the opposite sides, alternate sides. So angle 3 is equal to angle 5. So how do we prove this? So we know angle 4 plus angle 5 is 180 degree. Similarly, angle 4 plus angle 3 is 180 degree. So if you subtract, 4 will get cancelled. Angle 5 minus angle 3 is 0, which implies angle 5 is equal to angle 3. Similarly, if you take the other pairs, you will get this one. Second, next property is vertically opposite angles are equal. So vertically opposite angles. If you see 1, 3 is vertically opposite to it, right? Similarly, 6 and 8, 4 and 2, right? So angle 1 is equal to angle 3, angle 2 is equal to angle 4, angle 5 is equal to angle 7, angle 6 is equal to angle 8. So this is also 4 pairs. So how do we prove this? So if you see, angle 1 plus angle 2 is 180 degree, angle 2 plus angle 3 is 180 degree. So if you subtract, 2 will get cancelled. Angle 1 minus angle 3 is 0, which implies angle 1 equal to angle 3. Similarly, you can prove for other things. And then what we have is alternate exterior angles are equal. So we saw interior angles, right? 4 and 6, 3 and 5. So exterior angles 1 and 7 alternate, right? 1 and 7 and 2 and 8. Angle 1 equal to angle 7, angle 2 equal to angle 8. So how do you prove this? 1 and 7. So if you see 3 and 7 are equal because of corresponding angles. And 1 and 3 are equal because of vertically opposite angles. So 1 and 7 are equal. So you can use corresponding angles property and vertically opposite angles property to prove this. Okay. So this is with the straight lines. Next we will see about polygons. Polygons are nothing but closed figures formed by straight lines, straight line segments. So let's say this is a polygon. So any closed figure is also a polygon. So this is also a polygon. Okay. So minimum how many line segments you need to create a polygon? With 2 line segments can you create a polygon? No, right? So minimum you need 3 to form a polygon. So minimum 3 line segments are required. Okay. So in polygons you have something called regular polygon. So in regular polygon all sides, so side is nothing but each of these is called a side. Each line segment is called a side. All sides are equal and these are angles, angle 1, angle 2. These are called interior angles. And if you extend this and draw it, this is called exterior angles. See, if you extend and draw, extend and draw, extend and draw, extend and draw, these are exterior angles. So for regular polygon, all sides are equal and all angles are equal. For example, if you take a 3-sided polygon, so all its sides are equal and all angles are equal. So if this is 6, let's say this is angle A, this is also angle A, so this is some side S, this is also X. So since interior angles are equal, automatically the exterior angles also will be equal, right? Automatically the exterior angles also will be equal. So it is just sufficient to say interior angles are equal. So these are called regular polygons. So if they are not equal, broadly they fall under irregular polygons. But still there can be some special cases. So we'll see that later. So polygons can also be divided as concave and convex. So if you take any polygon, I'll take a four-sided polygon. So if I am able to connect any two sides, see, this is different, right? It is different from the actual side of the polygon. So these are called as diagonals. If all diagonals of polygon fall inside it, then it is called as convex polygon. For example, here all the two diagonals are there and both are inside within the figure itself. So it is a convex polygon. Suppose you take this kind of figure. If you see this diagonal, it is falling outside this region, right? So these type of polygons are called as concave polygon. So even if one diagonal is at least one diagonal falls outside the polygon, then it is concave. So there are special names for these polygons based on number of sides. So for 3, we said minimum it is 3. It is called as triangle. Tri means 3. 4, it is called as quadrilateral. Quad is 4. 5 is pentagon. 6 is hexagon. Again, pent means 5, hexa means 6. 7 is heptagon. Hept is 7. And then we have 8, which is octagon. 9, nonagon. 10 is decagon. Okay. So we saw what are the different polygons, and like there are other special names also for higher number of sides, but knowing this much is sufficient for us. So there are also other properties, like you can take the interior angles. For triangle, the sum of interior angles is 180 degree. So triangle, it is 180 degree. For quadrilateral, this is a special kind. The sum of interior angles is 360 degree. For pentagon, 5 sides, right? The sum is 540 degree. So can you see a pattern between them? It is just increasing by 180 degree, right? So for hexagon, it is another 180 degree, which is 720 degree. For heptagon, it is 900 degree. For octagon, it is 1080 degree. For nonagon, it is 1260 degree. And for decagon, it is 1440 degree. In general, for n-sided polygon, it is n minus 2 into 180 degree, right? So that is our first property, the sum of interior angles. Of n-sided polygon is n minus 2 into 180 degree. So if you see the exterior angles in each case, so the exterior angles always add up to, let's say this 120, 120, 120. The exterior angles always add up to 360 degree. So here it is 90, 90, 90, 90. So 490, 360 degree. Here it will be similar. If you add these, it will be still equal to 360 degree. So the sum of exterior angles is always 360 degree. So if you see, each side has one exterior angle. For triangle there are 3 exterior. For quadrilateral there are 4 exterior angles. So, and you see, for a regular case it is all equal, right? So for a regular polygon, number of sides into exterior angle is equal to 360 degree. So number of sides is 360 degree by exterior angle, right? So these are the basic properties, and interior angle also you can find for regular polygon. It is nothing but the sum of interior angles divided by 2 into 180 divided by total number of sides. So this will give you the interior angle. For example, for triangle it is 3 minus 2 into 180 by 3. So each will be equal to 60 degree. That's why I have written a 60 degree. So this is a regular polygon with 3 sides, which is a triangle, and it has a special name. We'll see that in the next lecture. Thank you.